If you're about to embark on learning about calculus, the big question I think is, well, what is calculus? And before I answer that, please like and subscribe. And I've got an entire playlist on both Calculus 1 and Calculus 2 that is being added to constantly, as well as other math courses. So here's what calculus is. You all know from studying math that slope is one of the most important things, right? We find the slope of a line, and this gives us a rate of change. And we, do a lot of things with that. We use it to predict the future. We use it to fill in missing points. But essentially, we say, well, if you move over in the x direction, what happens and why? And that's what we have talked about for so long in math. Well, calculus deals with, imagine if you had some curve and you said, I want to know what the slope is right here. And you certainly, using the tools from previous courses, could estimate. You could say, well, if I picked a point right there and I picked a point right there and just connected it with a line segment and then found the change in y over change in x, wouldn't that be a nice estimate of the slope? It would be. But could we do an even better job of figuring out that slope? And if you zoomed in on it and you said, well, what if instead of those 2 points, I pick points even closer, like that, and use that line segment? Or I pick points even closer and use that little line segment. And the goal is to zoom in so close that the change in x, this bottom piece, gets closer and closer to 0. And that's the first part of calculus, is figuring out how to find the slope of a curve. And it begins with this idea of what we call secant lines, where you just, pick 2 points, one on either side of the point in interest, and find the slope. But what happens is those points get closer and closer together. Now, the other part of calculus is we all know how to find the area under something like this. Like if I said to you, this is 5 and this is 2, what is the area under that curve? Well, it's 10. And we could do other things too. We could say, well, what if I had a curve that started at 1 and went up like this, and this is 4. You'd say, well, it's a trapezoid. And I could use, the fact that this side and this side are parallel, so those are my bases. And then the height would be this length right here. I could find that area. But if we introduce something like this, how could we find the area under that curve? And you might have lots of ideas of how you could estimate it. For example, what if you made like a grid system? You said, well, what if I did something like this? And then, something like this. And I made like grids and I counted up how many whole, squares were there. And then I, figured out like a partial square and kind of add them together. But calculus deals with the fact that we want to find the actual area. And one way that you could think about that is, well, similar to drawing smaller and smaller little secant lines, zooming in closer and closer on our point, what if we continued to divide these squares? What if we just kept making them smaller? And we're concerned with what happens as these bases go to 0. So in both the slope question and the area question, what we're really thinking about is getting such small divisions, and we call these divisions, as they get smaller and smaller, we say that they are defined by a limit. The limit in this case as this little difference in x becomes closer and closer to 0. And in this case, as these bases get smaller and smaller and closer to 0. This is what we're talking about in calculus. All of calculus is dealing with these two things. How do we find the slope, and how do we find the area of curves and things we have not been able to do before?